Hello, everyone. My name is Manoj. I'm part of cybersecurity domain for more than a decade. So I would like to talk about Palo Alto Networks. So since before like starting with like Palo Alto Networks, I thought of introducing the fundamental concepts of networking, which is the OSI layer. I didn't purposefully thought that I would be starting on Mahendra Singh Dhoni birthday, but I thought like having some analogy relation between Mahendra Singh Dhoni and OSI layer so that it will be interesting for you guys to understand. So let's get started. So what is the relationship between MSD and OSI layer? OSI layer is the fundamental layer for uh, networking. Meanwhile, please ignore my bad handwriting. It's been quite some time. I have written like in iPad and all. So let me go to the purpose here. So here you can see two buildings, right? Two buildings, two eight-story building, one, two, three, four, five, six, seven, and eight. So are you able to see completely? Okay, now you can see completely. Yeah. So the purpose now is the MS Dhoni fan wants to send a greeting message about his birthday. So he is staying in one of the five-star hotel. He's staying in one of the five-star hotels. Say this five-star hotel is T and this five-star hotel is M. So Mahendra Singh Dhoni is staying in this hotel, and MS Dhoni fan is residing in this T five-star hotel. So what he has done, the fan must send the greeting message across this building, and then it goes needs to go to this particular next building. Correct. So here below these floors, you can see there is water. So these two buildings are separated by water. So we need to get a step, pass to go to that building. So, let's say the fan gets his greetings from the post office. Yeah, he creates his own post office, gets the envelope from the post office, and ASCII is a photo printing company, which is in the sixth floor. And he gets the nostalgic pictures of MS Dhoni winning shots or winning matches, photographs, and all getting printed. Gets some cookies in the fifth floor and gets the pass for a seaport in the fourth floor. And third floor, he visits his Indian parents and then checks the price of MacBook because in the second floor there is an Apple Mac showroom. And in the first floor, there is a Manchester City match going on in the ground floor. So he goes through these many floors to reach the ground floor, gets the pass check from the local security guy, this guy, and then he needs to get travel to this building and reach the security guy, give his pass, and then goes through the same process to reach MS Dhoni in the eighth floor. So this is just an analogy. Okay, so the same principle we are going to use for the encapsulation and decapsulation process in the computer networking. So here you can see these two are, say for example, belongs to the same owner. The T hotel and the M hotel belongs to the same owner. Then you need not need a separate third party vendor to verify or to have a intermediate to check that parcel because both these officers are part of the same organization group. Although the names are different, they are part of the same organization group. They are allowing. Just say, for an example, these two buildings are totally a different building altogether, two different buildings belonging to two different organization or company owners. So in that scenario, you need a third party or like a separate intermediate person to allow this traffic. So here you can see uh, it has to go through the same process, like what I said, like the just the fan getting his envelope from the post office, puts his greetings, gets the photo printed in the sixth floor, gets some cookies. For MS Dhoni, gets the pass, seaport pass on the fourth floor, and gets the permission from Indian parents. Gets check the price check for his MacBook. He wants to buy some MacBook. So these are and all like for just giving you an example, okay? And then checks the score in the Manchester for the Manchester City match in the ground floor. Why I am giving this example is because I'm going to relate with the actual OSI layers. That is going to be a physical data link network, transport, session, presentation, and application. So now, if you see the comparison, you can see these are the layers, right? The actual physical layers are physical data link, network, transport, session, presentation, and application layer. So in this physical layer, you have the stream of bits being sent into the through the wire, the actual physical medium. You either use copper cable or the fiber optic cable. So in that cable, you'll be using the Manchester encoding. Okay, that principle of physical media works based upon the Manchester encoding. That's the reason I've given you the example of Manchester City logo in this building just for the comparison. Second layer, the data link layer. The data link layer is responsible for forwarding the Ethernet frames based upon the MAC address. So now you can see the MAC address is being associated in the second floor. And third, the network layer. So network layer is like routing the packets from one particular subnet or like from one organization to the other organization. So that acts like the gateway to traverse the packets from one destination to other destination. In our scenario, our Indian parents always been the gateway to decide our future. So I have given Indian parents residing in the third floor. And fourth is the seaport or the, I mean, fourth layer is the transport layer where you have the TCP and UDP protocols, where you associate the ports, the applications and the ports. Ports are being referred in the transport layer, in the OSI layers foundation framework. And then the session layer. Session layer is something like which is responsible for um, establishing the session, maintaining the session, and then terminating the session. So those sessions are like captured or like cached in the form of cookies. So that's the reason I have included cookies in the fifth layer. And then in the sixth layer is the actual representation of the data in the form of any standard format that is going to be like ASCII. ASCII is the American Standard Code for Information Interchange. So some of the bits are like going to be having some kind of value. For example, mm, 1010 will be represented as A. 1011 will be represented as B. So these are like a gateway or like these are like some except to all these concepts whatever am explaining is cannot be explained overnight because the whole internet works because of this OSA layer concept. So I cannot explain it by today itself. So now now we are into the sixth layer we have completed, and the final is the seventh layer, the application layer, where the actual applications you will be able to interact with from the client machine or from your machine. Like say for example, you want to send an email from the laptop. So there you will be using from the client machine, go to Google or I mean gmail.com, and then you draft an email, and then from that application, Gmail application, you send the data from your machine, and it traverses through the network, and then it reaches finally reaches the destination. So similar way, this is the overall analogy of the OSI layer uh, OSI layer framework. So in this specifically, if you focus, the physical layer, as I said, like is associated with the Manchester encoding, which I've already mentioned in the example. Manchester encoding. And then the second layer is the data link layer where you have the Ethernet frame being associated. So in the Ethernet frame, you can see the preamble, the start frame delimiter, destination MAC address, source MAC address, length data, and cyclic redundancy check for the integrity check. Preamble is the alternating zeros and ones for initially starting the packet flow. And then that is the start frame. Next is the start frame delimiter. And the start frame delimiter is the beginning of the signals. Okay. And then the destination MAC is the MAC address of the actual the destination remote host machine where you are going to reach the packet to. So you need to know that information. So for that, it will be sending the R packet. So R protocol. R protocol uh, is a protocol which is used to find the MAC address because that is the because you know the source IP, you know the destination IP, but you do not know the MAC address. Then there comes the R protocol with L to find the MAC address. MAC address is the one which we have already seen in this example, just to have a analogy relation to have a understanding. And then you have I mean, each field has its own significance. You have to go through the topics, and then comes the Ethernet frame. Ethernet frame, sorry, the IP header frame. I cannot even say IP header frame. It's IP header. So IP header is the where you are responsible for giving the identity, the version, the header length, the type of service, the total length, identification field, don't fragment field, mode fragment, fragmentation offset, time to live, protocol, header checksum, source IP address, destination IP address, options, data, IP4 header, and everything. So version represents the actual version because there are two versions of IP protocol, IPv4 and IPv6. And the header length is actually the length of the IP header, which is 20 bytes. And sorry, the initial header length. The overall IP header is 20 bytes, and the type of service is the which is used in the QoS settings and all. The total length is 20 bytes, and the identification field is like when the packet is sent, if at all that is, I mean, the maximum transmission unit of the Ethernet frame is 1500 bytes. So if at all the byte is going to be increased, it will be fragmented. So if at all it's going to be fragmented, there should be a numbering or like an understanding memory pointer to know that this particular packet is belonging to that particular packet flow. In that sense, the identification is responsible to give you that information. And in that itself, you will say whether it's enough to no need to fragment or like more fragment. If you want don't fragment, you set the flag df flag one and more fragment one on a flag set. And the fragmentation is offset is going to give you the exact position of that packet. Say the packet is split into three halves, and if at all you have received the second packet, that fragmentation offset value is going to denote that it is two. I've already told you that there are three packets being fragmented from the whole packet flow. And if you know that fragmentation value, you can clearly know that which particular packet is that flow is belonging to. So that is one. And time to live is the packet, like how long it can traverse for the transmission and the reception flow. So it depends on the operating system. So it also denotes the number of hops between the source and destination. And the protocol represents the actual protocol itself, the IPv4. And header checksum is like similar to provide the integrity check in the CRC in the Ethernet frame. So both these are like two give the header checksum or to provide the integrity check whether you're actually receiving the same packet from the source which has been sent. So that is the concept. Source IP address and destination IP address I have already told you, because the overall concept of networking works on the IP address. Only if you know the IP address, it can traverse from one node to the other host. And options and data are the other relevant things, because options is for study purposes, and data is the actual payload. And then above the IP header, you have the transport layer where you have the source port, destination port. Say, for example, the source port is going to be like a particular range starting from 1 to 1024, the well-known port range, and from 1024 to 65,335 as the next set of port range. So you have like several port numbers like 1000 so example like HTTPS is 443, HTTP is port 18. So those are all like comes under the destination port. The source port cannot have that, because the client is only going to more often going to initiate the traffic. So it's going to be having some random port number, and the well-known port numbers will be associated with the application itself. And the sequence numbering is the three-way handshake. You should know the three-way handshake. So three-way handshake represents the SYN-ACK and acknowledgement again. So client will be sending SYN packet. It will be having a particular sequence number, for example, 1000. And the destination host is going to send another SYN-ACK packet representing that it is going to send the receipt of 1001, because it shows that it has received 1000, and it's going to send the receipt for 1001. And then finally, the source is going to acknowledge for the next completion of that three-way handshake, that the communication channel is like fine, and it's like good to proceed with the communication. So these OSI layers are like later framed into TCP/IP layer. So as you can see, uh, these three layers are like same in the TCP/IP layer, physical layer, data link layer, network layer. And in the TCP/IP layer, all these remaining four layers are considered as TCP or IP layer, TCP/IP layer. So all these are like combined into a single layer, or combined into a transport layer. So that's the equivalent for like OSI layer to TCP/IP layer. So this is just a very generic introduction towards the packet flow. I mean, you cannot master this overnight. It really takes so much of experience to gain this knowledge, because each layer has its own it's like seven layers is like seven ocean to understand the computer networking. So that's like overall summarized view of these OSA layer, and with relation with MS Dhoni. I think I explained it in a better way. If not, please share your feedback in the comments. I'll try to improve better, and whatnot. It's seven layer is responsible for the internet to work, and what more, and it's Tala for a reason. Thank you.